Okay, so project one requirement, we just set up the project team, okay? Then you need to think about what program language you are going to use regarding to the database. It is MySQL, the GCP is the same thing, but the other, the setup, like the configuration, for example, if you are going to use a standalone Java, so you can mention about that. Or if you want to use the Python for the web application, what application server you are going to use. So for example, you can select the Django, or you can select the Apache server. So you need to select the web application server if you are going to use the web development. But as a backend, definitely we are going to use the database. So second step is the project requirement. Okay, it's just a description. As you have seen from your company, database description, we do not have data, so you don't have to describe each and every data. Instead, you need to describe the requirement. Okay, those are some examples, so you can get the idea of that.
Professor, the board.
And the third part is instead of a database query, so you can describe the functionality in English, plain English. Like the user can select the list of course, like that. Okay, user can select the previous semester course, or user can see the current registration information. The instructor can add the new course. So like the plain in English, so you can write the requirement. It doesn't need any knowledge on the conceptual design or the database programming. It's just plain in English. Okay, those are minimum requirements. Please make them more and more, so that will be safer for future. And if you have any assumption like the student can pay the tuition, but you are not going to implement the visa processing, right? So you can assume if user click, then we pretend the user paid for, so you can mark as paid. Do you understand what is such an assumption? So you can, if you have any such the condition, so I'd like to implement a payment option, but you don't have to practically implement. Instead, you can. I think only one time, one student really implement such I think through the people, third party tool. So he implement a payment option, but you don't have to. At the time, you can mention. So we assume the payment transaction will be done at the third party. Then you can mark as a paid. So that is a step 4. So it's phase 1 is just documentation. Okay. By the next week, so please work together one more time because some of the students come in. So this is the current project lineup. So group number 1 is the self-assigned, so no problem. Group number 2, Tanya and Nikita. Okay, so no problem. And group number 3 is right now is alone. The Jake and Ada. Jake, you are working together. Okay, you are the only remainder of undergraduate student. Okay, and group number 5. Lamberhart, Sri Lau, is it okay work together? Okay, and I think that you can work alone. Okay. So any question regarding to the project setup? Okay, thanks so much. So please keep working together with your project partner. If you have any problem working together, let me know as soon as possible. Okay? The only option is we can split and you can work individually. So it doesn't require to work as a group. So if you want, you can work alone. Let me check one more time for the attendance. Sri Ram, yeah. And Bodhana, okay. So that's it. And also next week, we are going to have the first exercise after we complete the ER and ER modeling. So for the modeling practice, we are going to use the tool, Allwin software, or any similar tool. So I'm going to GA will announce what kind of software you are going to download and install on your laptop. So next week, the Thursday, you can bring your laptop, then we can practice in the classroom. So how to use the software for our designing and the practicing. Okay, so any questions so far? So we are doing I like this slide. This is overview of database design. In your programming class or software engineering class, you already did the left-hand side of the process. This one, functional analysis, application design, then you implement your software, right? But even though you do not use the database system, in your programming, so you already use such a data and the memory-based data structure. For example, you can manage the customer using the list or the tuple array, or even you can create the file, then store the data. Whenever you need, you can read. So these are done through this left-hand side process. However, when we have very large data, so as we discussed before, so we need to manage such a very large data differently. Differently means the different data structure. That is the database model, data model. So among the different database model, we are going to use a relational database model. So this process includes several the steps. So first, we are going to design based on the conceptual. Conceptual means based on domain knowledge, we try to grouping important or related information. Last class, we just started using the entity relationship model. So we find the entities from the requirement or the data. That is conceptual design. Then the logical design, finally physical the design for the data and database model, then combined with the application analysis. Finally, we can have the database, the system. Database system includes the database design, database implementation, and application. Then from the application, we are able to access the data. Okay, please keep in mind throughout the semester this the designing process. Then today we are going to continue the conceptual design. So among the conceptual level design, we are going to use the ER modeling. So ER modeling is one of the most popular data modeling. It's not database yet. It's just data modeling from information. Information in my class, so it's kind of the vague. Everything is the information. We are not going to manage it or collect or keep track of such all the information. Instead, based on customer requirement, we try to collect the important and also meaningful and also related information. Then we need to combine. So how? At that time, we can use the entity relationship model. So for the ER modeling, it's very simple. One of the benefits of using ER modeling is it's simple. So by taking the 1 or 2 hours class, you can do it. Everybody can do such a ER modeling because it's kind of intuitive, the data modeling process. So we try to formalize such a step in this class. So last class, we are going to use a sample database. So this company database will be used throughout the semester. So you don't have to memorize the requirement, but you can imagine in your mind. So our sample company database consists of something department, employee, project, dependent, and so on. Okay, so let's follow the conceptual design ER modeling step. So first step was we are going to find entity. Actually, this is the entity type. Do you remember that? Entity means each and everything. So for example, if I'm going to model the student, so Aaron is the one entity, and the Amar is one entity, and the entity. By combining all entity, student entity, I can realize I can find the common information, name, ID, address of Aaron. Name, ID, address. Name, ID, address. Even though he has the hobby, but it's not important information. We ignore. That's kind of the problem of the relational database later. What if somebody wants to access his hobby, but it's not in database? But we are going to eventually later, relational database. The one of the benefit of using relational database is it's standardized. It's only common information. That is one crucial part. But nowadays, it's different. So NoSQL database later, we need any information. Who knows? Somebody needs his hobby. Somebody needs his the habit or eating. So everything we can put together in the NoSQL database. Okay. So later I will introduce a little bit more about such a NoSQL database. But right now we are going to keep only name, ID, address. Name, ID, address. So like that. So by combining such the common information, we can find attribute, name, ID, and address. These are called attribute, attribute, attribute. By combining this, we can find student, the entity type. So this is the entity type, okay? But interchangeably, we can use the entity and entity type. But you can differentiate. Entity means what in real thing. Entity type is the list of attribute for that entity type. Okay. One more thing is I forgot to mention the last time. One more thing is for example, name Lee, ID 111, address is Bridgeport, and James and 112, and Trumbull, and so on. So this is called the entity type. This is the entities. By combining entity type and entities, okay? So we are going to call this is the entity set. Okay, so entity set include everything. So entity type and the entities. However, I never use the entity set, name of entity set in the real project. Okay, everybody say it's an entity. Okay, we can use it interchangeably. So for example, your project manager asks, find the entity. Okay, which entity is missing, something like that. So entity means this schema entity type. Okay, so then from company database, last class we find several entity type entity. So first is the department. Department. And second thing is the project. Third, employee. And last, the dependent. So it's not required. It's a case sensitive. It's not case sensitive. However, most of the ER diagram, ER modeling, they use the capital letter for the name of entity. Okay. So, but it's not required. It's just for better readability. Then, after we find the entity, so to make us easy to understand such a design, we'd like to use the diagram to represent the entity. So we are going to use the rectangle. Okay, it's not the standardized diagram. Okay, if you take a look at the textbook is similar to this. I'm going to use a textbook notation, but the other textbook use a different notation. How many of you use the UML diagram? UML diagram? You can use the UML diagram to represent this one. Very similar, right? So, and for each entity is the object, and we can list the attribute, and also you can find the key, right? So like that. You can use the UML diagram. You can use the different notation, industrial notation, whole food notation. But in this class, in our class, we try to follow the notation suggested by the textbook. So this is our notation. like this. Okay, then after we find the entity type, then we are going to find the attribute that describe each entity type. Okay, so it's not from your idea, or it's not from your experience, from the description. Anyone who do not have the handout? So, from the, for example, the first, the blood department has the name, the number, and the manager, and the start date of the manager, and the department has several locations, like this. You can find as many attributes as possible that describe this one. Actually, sometimes in real project, it's not, your customer is not like such a nice, okay? This one is really nice and ideal case. They will give just a bunch of list of department. Then you need to even the name, okay, of attribute. Name of department, number, and the manager you need to find. At that time, it may be possible like you can name the attribute like the A1, A2, A3. But can you understand the meaning of attribute? Yes? A1, A2, A3? No, definitely not. So it's really happened. But think about you're the homework. Sometimes if you create the temporary table, like the table is a T1 and the column name is or variable, V1, V2, V3 in your programming. But it's kind of a habit. Please, you don't have to sometimes follow in database. We do not use the comment style, the naming group, or the object-oriented programming, the object naming rule. Like the first letter is the A, B, C. It's a class naming group. Okay, or the comma. This is a comment, and you can use the underscore, A, B, C, underscore, the D, E, F. So Python preferred this one. But the database does not follow such the naming rule. Instead, the capital letter or the lowercase letter. So for the attribute, lowercase letter, and also meaningful. If somebody can understand the meaning of that, it's pretty much okay. So also, most of the time, your project manager will give the naming group policy in the project. Okay, it should not exceed the 30 letter, and always start with certain identification and so on. So you need to follow such a naming group. Okay, then the project, the project unique name, and the unique number and location of that. Is it possible to use the same name of an attribute for the different entity? It's okay. However, if you want to really make sure they are different, you can have the surface, like the department name, D name. And this one is the project name, P name. This is also a good idea to make the meaningful for better readability. Okay, like this. And for the employee, social security number, and the address, and salary, sex, and the DOB, birthday. And for the dependent keep track of name, and sex, DOB, and the relationship. So as we discussed the last time, so we try to use the over and connect to the corresponding attribute. So like the location, D name, D number, manager, start date, and the P name, P number, location, social security number, this one, relationship, This is what we did the last class. Before we move to the next step, there are different types of attribute here. So most of them is a simple attribute. So actually, there's such a simple attribute. As I mentioned before, first when we design the entity and entity type and their attribute, it starts from the data. Each data is a value. So this is the attribute coming from the value of data. Okay? So this attribute, that is a simple attribute. In terms of the ER modeling, the relational modeling, later, this value is considered as a domain. So domain is, for example, the department name. There exists a big jar, okay, where it consists of possible department name. HR, IT, department number 1, admission, administrator, executive, such a name of department. From that, the department name domain, we can select the value for the D name, like that, such a concept. This is a conceptual level because we do not know what is a string. We do not know what is a number, what is a float, what is the double. Okay? This is not related computer science or any programming. Only conceptual level. So there exists domain for the each attribute. Then we are going to select the one value from the domain. Okay? This is actually idea of the relational model later. So I will introduce more later. So that is a simple attribute. There is the more complicated attribute, for example, address. In case of address consists of what? For example, 100 Bridgeport, a university. University, Avenue, and the Bridgeport, Connecticut 06604. Street number, street name, street type, and city name. There's a state name and the zip code. So address consists of several the part of the information. At that time, this kind of attribute is called composite attribute. So there is another type of attribute, is a composite. So for example, address has the subclass of the information. At that time, we can use street name, and next the city name, and state, and zip code. And each of them will be sub-attribute, then connect to the combined one. So kind of we can use the tree structure to make the information attribute information detail. So in case of the composite, we can use such a detail or child with attribute. Okay? But question is, how can I decide whether this is simple or composite? Okay. First, check the data. If data is like can be partitioned, divide the sub-information, you can. Also, you need to check customer requirement application. Sometimes, when you sign in the website, you can type entire your address for the address form, or some of the signing process require first address 1, address 2, city name, the state name, zip code separately, right? Most of them nowadays. So at that time, if your application requires separate address 1, city, state, and zip code, you can design such a way. Okay? It depends. However, if your application or if your customer do not need such the separate information, you can create a simple address, the attributes, like this one. So there's no general rule or guideline, but depending on your the requirement, you can decide whether simple and the composite address. Okay, that is the second case. Any other? I don't think we can find any specific the composite case. That's the address. So third one is multi-valued. Multi-valued address. For example, our requirement clearly mentioned the first block, a department may have several locations. Okay? So in this case, this is a multi-valued. For example, the department has the New York office, the Dallas, and LA. Like that, it's a multi-valued. The other department name is one. Department number is one value. Manager, one manager. And the project name is a one value, but this one has a multiple value. So we can represent such a multiple value with double over. Okay. What about the project location? Is it multi-valued or not? Read. Check the project. Second. Unique number and is located at a single location. It's really clarified. It's one location. Later, I will explain why multi-value is identified. Why is it important? Okay, later. We set aside for future. I will explain when we talk about the relational database model. Okay? So multi-value. So, one more thing. It's not type of attribute, but we need to identify key attribute. What is a key? Based on your experience around the computer science or the computer engineering major. So what is a key?
Is the value assigned to identify the...
Identify. So
unique.
one unique. And actually it's not required. The key should be unique. For example, there is a master key. Master key can work all the part. But later we need the unique the key, but the key is used for identifying. Key is a key, so important. And the key can be used to access this room. Key is the not key. What is the most important? The objective of using computer. Why do you use computer? Eventually, we need to get the information what we need fast, efficiently. Calculator. What kind of information? Like arithmetic, the operation, output of arithmetic. Like the 1 + 1 is equal to 2. We try to get 2 very fast. So in terms of the kind of the database, everything is a search. Okay? If you type something, output, it's a search. Okay? If you run the program, output, input and output is kind of search. So when we get the search such a data, what is the best way? If we have the unique the value, like the UBID, it's the best way. But if I'm using the very common the name like the James or Smith, Nick or Potter, sometimes several students will answer. So such a key is that if key is unique, it's the best way to identify the data. So from that point of view, can we find any key attribute that can be used for identifying specific entity? For example, department. D name. Let's see this one. Department. Each department has a name and the number. So nobody wants to create the department having the same name, right? Computer science and engineering. Electrical engineering is different. So this name and number can be used for identifying. the specific entity. At that time, this is a key attribute. So key attribute, we can underline like this. What about the project? If you read the description, it's clearly mentioned. Unique project name. Unique the project number. What about the employee? Even though it's not mentioned social security number, definitely unique. Okay? Then address maybe not, salary maybe not, so not. What about the dependent? Can you find any key attribute? What about the name?
Could be similar with someone.
Could it be same? So for example, you and me, both of us are in the employee, but I have a child named Nick. He may have a child named Nick. Okay? It will be the same name, same last name, it's just we cannot use for identification. So at that time, its name can be used, but it's not actually the unique. But it may be used for identification, right? How? If we know the employee who is related to the dependent, we may know. At the time, this one is called the partial key. So partial key is not unique, it's not, but it may be used for future. So at the time, we can use dot line to represent the partial key. So we can identify key or partial key attribute. So key attribute definitely can be used for to identify the data. Partial key may be used for future to identify the data. Okay. So after we identify the attribute, so one of this we need to decide the simple, composite, or multivariate. Then also if there is any key, we can underline. Question. So key attribute is required for the entity or not? Yes or no? Key attribute is required for each entity. True or false? It doesn't have to. Okay, sometimes entity may not have key. For example, nowadays, no SQL database. So there are duplicate keys. That is the reason I said key is not always unique. Okay? But it can be used for the key. So it doesn't have to be unique. And so it may not have. However, later, everybody knows in computer science, computer system, if we have the key, unique key is the fastest way to search the data. So database later definitely need the key. Okay? Even another question. When we have a key attribute, it should be the just one key attribute, or it can be the multiple key attribute. Yes, we already have the two key attribute for the department. Two key attribute project. So one for employee, nothing for the department, dependent. So it is okay. Nothing key attribute, or one key attribute, two key attribute, 3, 4, it is okay. But later, have you ever heard about the primary key? What is a primary? It's a primary, most important because of this. Sometimes we may have several keys, so we can select one of them as a primary. That can be used for really identification. Okay? Later we will talk about such a primary. But key attribute, it can be 0, it can be 1, it can be multiple key attribute in the ER model. Okay. Last one for the key attribute. Sometimes key attribute is the D name and D number. It's not unique, but if I combine D name plus number is a unique, that may be possible, right? It's a composite key attribute. In that case, if you can identify the composite key attributes, you can connect with this. Okay, if you can see the connected, the key attribute, that means one key attribute, but this is the composite key attribute. Okay, So in your database design, if you can identify such a composite key attribute, please connect. Okay. However, if we're not connected, that means this one is key attribute and the number is also key attribute. Okay. Any questions so far? So it's very straightforward. The next step, third one, relationship. Okay, let's take a look at the requirement also. Okay, so if you go to the third block, employee social security number, employee's social security number, address, salary, sex, and the birthday. Then there are sub-block. So see, sub-block. Each employee works for one department, but may work on several projects. You cannot find any new attribute. We already identified the attribute of the entity, but each employee is here. Each employee entity works for one department. It's not an attribute, but that is the important information. If I write down the example, Lee work for HR department. Okay? Or James work for IT department. And also Patel work for IT department. One department is okay. And also the Nick work for the project one department. So admin department, like this. There is no new attribute, but there might be important information. At that time, we can identify this is what? Employee entity. This one is department entity. Then we have work for. At this time, this is called the relationship. So relationship is related to two entity type. Two entity. One is the employee here, another one is the department. So this is one relationship, another relationship, another relationship, another relationship. Then if we grouping, this is the same relationship between employee and department. This is called relationship type. Just like the entity type. By grouping entities, we can find the entity type. By grouping and relationship, they have the employee to department relationship. So this is called the relationship type. Okay? So the third step is identifying relationship type. But just like this entity and entity type, we can use interchangeably. So most of the time, you will use find relationship, not relationship type. But you should identify what is a relationship type and what is a relationship. By combining these two, relationship and relationship type, this is called the relationship set. Okay? So the relationship set includes the relationships and relationship type. But we are going to use the one name, like the relationship. Okay, let's identify the relationship. First one is employee work for department. Employee work for department. Right? But how to represent nicely? So we are going to use the diagram. Lumbus diagram. Then connect two entities. So for example here, work for employee to department. Like this. Okay? So let's identify the more relationship type, relationship here. What else? So but may work on several projects. Employee work on several projects. So this will be work on several projects. Okay. Then next, second subblock of employee, we could keep track of a number of hours per week that an employee currently work on each project. There's no new, the relationship is already mentioned. And also keep track of the date. We will check that one is later. Let's go back to the first bullet. Okay, so department, there's no relationship we can find, right? Can you find any relationship? What about the manager? So we create the attribute for the manager, but manager is actually employee. It's we don't, instead of creating attribute, we can create what? Employee manage the department. So we can create the relationship manage like that is. Okay. What else? The second bullet. The project. Each project has a unique. First, each department control a number of a project, which means each department control number of project like this. Okay. That's it. And what else? The last bullet, dependent. Each employee may have a number of dependents. So has. Each employee has number of dependents like this. Okay. Anything else? Oh, we missed the third subblock of employee. We keep track of direct supervisor of each employee. What that means? The third subblock of the employee, we keep track of direct supervisor of each employee. In other words, each employee has supervisor. Think about the case. So, Lee supervised Patel, and Lee supervised and James. James supervised me. Like that is. Employee supervise employee. It's a relationship, but employee to employee. It's the same entity. It is also possible. When you search, when you find a relationship, that relationship is from two entities, but there can be same relationship. So, for example, here, if we identify the relationship, supervise, then from employee to employee like this. It's the self-reference. So employee supervise the employee like that is. Okay. So we identify the whole relationship. Okay. So this is the relationship or relationship type. However, sometimes you can find attribute of the relationship. So for example, if you read the work on, the second subblock of the employee, we keep track of a number of hours per week that an employee currently work on each project. One employee can work on the project 1. How many hours? 10 hours. Lee work on project 2, 20 hours. Lee work work on project 3 5 hours, like that. And also James work on project 1 10 hours, and so on. We already identified the work on, but what about this number of hours? It's the attribute. So this attribute cannot be project attribute. This attribute cannot be employee, because employee work on this amount. However, in terms of project P1, we cannot identify specific hours. So we can create the hours as an attribute of the relationship. So relationship can have the attribute also. One more thing is, if you see this manager, where's the start date? Start date of what? Manager. So start date can be the attribute of the manager. Manage at relationship. Okay? If we put the start date to here, not all employees are manager, right? You may put the start date to the department, but it's a start date of what? It's a manager information. So this is the attribute of that. Any other attribute can you find? I think the pretty much. Okay. So this is the attribute. When you create attribute, it's over and connected to the relationship. Okay. So pretty much done. So one more thing. It's called the weak entity. So when we identify the entity and their attribute, we identify key attribute. Most of the time, not always, most of the time it has key attribute, key attribute, key attribute. But dependent does not have a key attribute. We cannot identify specific dependent using name. However, as we checked before, if you know the employees, the least the need, and somebody's need is different. So if we know the employee, then we can identify the specific dependent. At that time, if entity does not have the key attribute, instead only partial attribute, we are going to, this is the weak entity. Opposite of the weak entity is just the normal entity, like the having key attribute, key attribute, key attribute. So at that time, we can use the diagram to represent the weak entity as the double rectangle. So weak entity has only partial key. So it cannot be used for only this weak entity to identify the data. Instead, connect to this one. At the time, this relationship is called identifying relationship. Identifying relationship. So you can use a double numbers, double diagonal, like this. Okay. So we covered up to the weak entity. Then there are several more the minor thing. It's not minor, it's important also. Let's take a look at this one, relationship. Go back to it. Let's go back to your elementary school, the math class. Do you remember? So such a B, C, 1, 2, 3. Like this one. So it's called the one-to-one mapping. If one element of a set is mapped to another element of the set B, then this is called one-to-one mapping. You see, Venn diagram, something diagram, well, I cannot remember. But this is the very basic concept of when you start to learn the algebra function. So before function, you learn about the mapping. And there are different types of mapping. It's a one-to-one mapping, one-to-many mapping, and also many-to-one, many-to-many. Okay? So actually many-to-one-to-many, many-to-one are the same. So there are different types of relationship. That is the constraint. The next one is a constraint relationship. So constraint relationship means first decide one-to-one, one-to-many, and many-to-many. So we can use M or N to represent the many side. For example, for the department and the employee. One employee work for the one department, right? It's clearly mentioned here. However, from the department side, many employees. One department has many employees. Their relationship is one-to-many. Okay? One department has many employees, or many employees work for one department. So their cardinality is one-to-many relationship. What about the manager? One employee manages one department. One department is managed by one employee. It's a one-to-one mapping like this. At that time, we can write one-to-one as a subscript on the line to the entity like this. We keep going. What about the supervisor? One supervisor. I'm supervisor. I have several employees, many. However, how many supervisors I have? Only one. So it's a one-to-many. One-to-many side. To clarify, many side is a supervising. And one side is supervisor. You can specify such information. What is this one? Employee. How many? Dependent. Many. How many employee? How many parents? Only one. So one-to-many relationship. What about this? Employee to project. One employee work for many projects. Do you remember? Work for the project 1, project 2, project 3. Because of that, we have a number of hours. However, project has many employees. So this is a many-to-many case. Don't be confused. So because of that, it is very important to check the data. Okay? Sometimes from the description, it's not clear. So you'd better take a look at the real data to decide the cardinality of the constraint of the relationship. One more, control. One department control many projects. One project is controlled by one department. So it's a one-to-many. Don't be confused. Many-to-one, one-to-many. So always think about one department control many. Then you can decide the many. Okay? So this is the constraint. It's called the cardinality. You can decide the cardinality. So best way to decide the cardinality is real data. Otherwise, you need to analyze the requirement and determine such a thing. One more thing. So, for example, manager. Not all employees are manager, right? Some of them are manager, some of them are not manager, which means not all employee entity participate in the managed relationship. So, in other words, it's optional. However, each department must have one manager, right? No? Yes, so each department has at least one manager, but employee is not required to be manager. Some of them are managers, some of them are. In case of optional, we can use the one line, single line. However, if that is required, so like for example, the manager, we can use the double line. So one line is the optional participation. Double line is the mandatory participation. For example, this. From employee side, it's not required to have dependent. I'm single. I do not have dependent. So, but some of the employee have their dependent. So this is optional. However, from dependent side, if you are in the dependent, which means there exists related employee. So this is the mandatory. So if you can find such a mandatory participation, double line. What about this? Work for. Let's take a look at each employee works for one department. It's not clear, but if you believe, at this time, if you believe it's required, you can use the double line. However, if you are not clear, you should not, because the double line means it's a very strong constraint. It's a very strong condition. Okay? If clearly mentioned, like at least one, or if you can find the data from the data, so you can decide such a participation. Okay? So I'm not going to go over the other, but in the project, like the UV registration system, when you are doing the conceptual design, you are the one who decide whether this is a mandatory or this is optional. Okay? Okay, so this is the constraint of the relationship. Okay. I think that pretty much that's the older thing. Okay? Then any missing part? I think that we did. So why don't you compare with we did everything. With this. Okay? Let's see. So we have the employee and their attribute. Name is composite. This designer decide name can be separated. Like the first name, middle name, initial, last name. So composite attribute. And the department, so work for, in this case is one to many, but double line means what? Mandatory participation. This designer, the belief, department should have at least one employee. Why? Manager. At least one manager employee. And also employee should be assigned, must be assigned to the department. So it's a double line. And the start date. And work zone is the same thing. Double line means employee should have one, the assigned project. And the project should have the employee at least one. But department and project, some of the department may not have a project, but project should have the controlling department. You can understand this. And the dependent, we can use the double numbers and double line for the entity because it's a weak entity. We can say that dot line, the weak entity. And this one is called identifying relationship. So double the numbers. And I think that the diagram and our diagram are the same. Okay? Except there's one the dot over number of employees, which is not important, but sometimes your requirement, I'd like to manage the number of employees for each department. Actually, number of employees, how can you get the number of employees? You need to check this one with the relationship, right? Actually, you do not have to manage the number of employees, but it is called a derived information. So, whenever you access the number of employees for a department, you need to go to the employee, check the department, and count. Takes a longer time to save the time, we can create such a derived information, inferred information. So at that time, you can create a dot line. It's not required. It can be used for what? Specific application. So probably this attribute is identified through the application analysis. Okay? Then otherwise, it's the same as this. Okay. Okay. Any questions so far? It's very straightforward. So let me summarize in 5 minutes all the ER modeling process. First, from sometimes data, sometimes requirement, sometimes both of them. Okay, these are the basis. Even though you have really a lot of experience and you did design for the company, so that is the next thing. First, based on the requirement, first based on the data, we are going to design the company database using ER modeling. First step is identify entity type from entities. So this is entity, this is entity, this is a weak entity. In case you cannot identify the key, weak entity. This is an entity. Then to represent such the model, we are going to use the diagram. This is called the ER diagram. Okay. So if further using the ER diagram, we can use a rectangular. Then there are attribute. Attribute. There are different types of attribute: single attribute, composite attribute, and multi-valued. So in case of a composite can be separated by the subclasses like that. We can use the kind of the tree structure to represent a composite. How do we decide whether this is a single or a composite? Requirement. From the requirement. Like for example, the name of the employee. Where's the name of employee? I think I forgot the name of employee here. Name of employee. So name can be a middle line initial, first name, last name, or together. And also, if you can identify the attribute, that can be used for the identifying. So it's called the key attribute. So key attribute, right now, it doesn't have to be the unique. In case it's not unique, it can be partial key. And otherwise, so it's the key. It may be composite, at that time you can connect. Okay, then the next step is the relationship type. It's related to the multiple entity. It doesn't have to be same. Sometimes like the supervisor relationship, it can be employee to employee. Okay, but still the same, the characteristic. So after you identify the attribute, the relationship, not always, but sometimes we can identify the attribute for the relationship. Specifically many to many. Many to many case, we can identify the relationship, the attribute for the relationship type. Think about this, it makes sense. So one employee works for many projects, and each project has many employees. How many hours? We cannot use the employee, we cannot use the project, we need to use the in middle, that is the relationship, number of hours. Later, when you design the database, many to many is not allowed. It's additional. Not the ER model, it's a conceptual level, but later database model. So many to many is not available. This will be separate later. Because you can create the work order. Like this. Then the employee, the one employee, many. One project and many. Like this. Okay. So we will see later. Just for your additional information, many to many relationship will be actually the separate to the one to many, one to many. Because no way to handle the many to many. If you have many to many, it's not easy to search, right? So you don't know which one is which. Instead, we can create another entity for those outcomes. But this is the next thing. We will see probably next week or the week after for this one, a week after. Okay, so this is a many-to-many case. Then for the relationship, we need to identify whether this is one-to-one, one-to-many, many-to-many. Okay. At that time, how do we decide? From the data and requirement. Then another thing is optional and mandatory. You should be careful to decide the mandatory. So in case of mandatory, it's a very strong constraint. Okay. Later, when you create the database, this will be the constraint of the database. So if you are sure, then use the double line. So it's a mandatory participation. Okay. So this is the overview of the ER model. For your practice, by next class on Monday, Tuesday, without using any computer tool, just scratch paper and follow the step over here. Why don't you draw the company database ER model? It's for your practice. Okay, so easy to understand, but the more important thing is your experience. Okay, ER model is even the middle school, high school student can understand. But the more important thing is more and more you practice. So first time, then use the diagram. So why don't you draw the ER diagram? Exactly same as this one on your paper. Okay, do not print out. Just for your practice, just hand drawing the ER diagram and bring the paper. Second homework. So even though we are going to practice with the several sample database, but it's not the good enough the cases. So to make the enough case, we have the 10 students in the classroom and total. So why don't you make, it's not the UB registration database system, find or create the sample database. Like I'm interested in the NHL hockey. Okay, so you can create the project description. It's a half page long, half to no longer than 1 page. So half to 1 page description, like the clear description, like this one or the company description. Create a sample database description and it's the solution, your solution, ER diagram. Okay, it's based on your interest. You can use Google search. You can use the other textbook. So, but I already did the same project, but a lot of students search the Google, and first one is the hospital management, and the second thing is the what is the logistic company, the FedEx, and such a UPS management, and the classroom management. Those are the very popular, but please find the interesting, but clear. Okay, the description should be very clear. Okay, so second homework is find the sample or create the sample database, half page long, and create your answer, the ER diagram, by following this one. Then I'm going to use one of your homework for the midterm exam. This is what I'm doing the last few semesters. It works very well. And you guys can practice with the 10, at least the 10 homework, 10 database. Okay, then if your homework is selected for the midterm, it's almost 60% of the midterm exam. Because eventually we are going to use the ER model, database model in the database design and the SQL. I'm going to use your homework as a sample database for the midterm exam. So please do your homework. It's clarified. If your description is not clear, your database will not be selected. So please make the clear. You should rewrite, paraphrase. Like if you want to make the key for the specific information, unique number like that. Please create. Also, it's a good idea to use the bullet style, clarify such a description. Do not copy and paste the bunch of data. Okay. So just a half page long or the maximum 1 page, then create. For the ER diagram, right now we do not cover the modeling tool. Instead, you can use Visio, you can use the PowerPoint, you can use the Word, but it's not recommended to hand drawing and take the photo. Sometimes not easy to understand, but if you do not know how to use any diagram or whatever, so you can use the handwritten and drawing and take the photo, but it's last option. So please try to use such a tool. But if you study in advance, so you can use any modeling tool. But we are going to cover the modeling tool next week, the Thursday. Okay? So what time is it?
45.
45. Okay. Any question? So 2 homework. One is using scratch paper, company database, just copy. Okay, so for your practice. Okay. Second homework, submit your sample database. It's not company, it's not university, it's not popular. Just based on your experience, either your preference, the half page long or the maximum 1 page description with your solution. But submit to the Canvas. Okay, by next week Thursday. Okay, that is by Thursday. It's a submission. Okay, clear? So I'm going to create your homework submission on Canvas ER diagram. You can submit. Then one selected one will be used for the midterm. Any other questions? So next week we are. This is not it's too easy. So there's another thing, extended ER modeling, because sometimes the data is not that simple. So we are going to add a couple of more things to the ER model, which is called the enhanced or extended ER model next class. Then followed by the exercise lab for the modeling tool. Then we are going to move up to the database model with that. Thank you.